Good. So we have to also, because in your book, they have written it very precise, right? The people who have written those things, all those physics one. So in the first 2 or 3 pages, you will see those names, right? And those are our teachers, our senior professors, right? So if you look at those names, they are the most senior people which can make or which can make those kind of books, right? So that book is very precisely, very accurately. And to understand that book, we have to also use some reference books. And that is how we understand those things. So we have to elaborately uh, discuss all those things which are written in this slide. So by just copy pasting that, no one can understand it, right? Even we have some trouble understanding because they are written very precise and word by word we have to understand. Right. So you can just look at those uh, cover pages of those books, right? So many people have written that. Many are professors from Delhi, professors from different parts of India. So they have written that book, right? Okay, so the next projectile one we have finished, right? Any questions from projectile, from derivation to all the other things?
No,
Any
sir.
question? Okay, so yeah, you remember that this one is the most important thing, right? This relation of, what is this relation called?
Equation of trajectory.
Also, that is written upstairs. Yeah, that
Mhm.
is correct. So equation of trajectory which relates y with x, right?
Yes, sir.
So previous question was very important, and we used this relation to get the answer, right? So,
Yes,
and we use, yeah, and we use some trigonometry as well. So this point was a comma h, y was h, x was a, and then we solve this one. So next topic of this chapter is relative motion, right? That we have already understood, but in this chapter, uh, we will understand relative motion in 2 dimensions, right? So the object is moving with respect to in 2 dimension, right? So let's say if let's say I have two objects. One is let's say moving in this direction. Let's say this is VA, right? And the other one is moving in this direction. Both are moving. So we use, when do we use relative motion? When do we use that? So we use relative, right? Meaning that we are comparing. So when do we use relative motion? Can you tell me? The
for
answer
com
is yes,
for comparing.
comparing, but when? When do we compare?
When there are two uh, things given, like
Yeah, you are nearly given. Oh, so whenever we have two objects, both of them are moving. In the earlier cases, we were measuring the velocity of car, we were measuring the velocity of something, we were measuring the acceleration, we have written the kinematics equation, all those things, projectile motion, all those things. We were studying those things with respect to ourselves. And we were what? We were what?
so. Could you repeat? I didn't understand.
Yeah, so in the previous scenarios,
Yes, sir.
when we were discussing projectile motion, when we were discussing kinematics motion, when we were discussing all those things, right?
Yes, sir. Yes, sir.
So we were observing those things and we were the observer, right?
Yes, sir.
And most important thing about us was that we were stationary,
Yes,
right?
sir.
Were we moving?
No, we were not moving. The object which was moving, we were observing when we were
Yeah.
stationary.
So only the object was moving, right? So in that scenario, only one thing was moving, right?
Yes, sir.
Now, in some cases, what happens is that let's say you are traveling in a train, right?
Yes.
You are traveling in a train and some other train is crossing by, right in front of you. So you are traveling and the other train is also traveling. In that sense, in that case, what we will use? We are not stationary, right?
So we are standing and the train is moving.
Yeah. So the train is moving and we are moving along with the train, right? So which
Okay.
means that we are also moving, right?
Yeah.
So we are moving and the train in front of us, that is also moving. So in that case, what motion we will use? This is train. Let's say train 1. This is train 2. And in the window, we are seeing that thing. So this is us, right? So we are moving, train second is moving. So in that case, we have to use the relative motion of us with train, right? And that
Along
we
with
talked
the.
to, yeah, so that we understood that this would be VA minus V, right?
Yes, sir.
So relative motion of A with respect to B, right?
Yes, sir.
So this is the person, relative motion of us with respect to that train. Or we can also calculate relative motion of train with respect to us, right? So VB, that would also be VB minus V,
Yes, sir.
right? So whenever the two objects are moving, then only
Relative.
we use this relative motion. So that is the idea of relative motion, right? So in
Yes.
this case, two objects are moving, so we use relative motion when the observer and object both are moving, right?
Yes, sir.
And how do we calculate the relative motion? So the relative motion of A with respect to B, that would be simply VA minus V. And in one dimension, we have done this, right? So
Yes.
in this case, the train will appear faster or the train will appear slower. This one we have already done, right?
Yes, yeah, it will be slower because we are moving.
Slower.
I mean, when we are moving along with it, that time it will be fast.
So whenever the two trains are moving in opposite directions, then velocity will add up, right?
Yes, sir.
And why velocity will add up? Because let's say that this is I hat, this is minus I hat, right? If we subtract these two, so this will VB is I hat, right? Some velocity, let's say V1 I hat. This is minus of V2 and minus of I hat. So this will become what? V1 I hat plus V2 I hat. So this one be V1 plus V2 I hat. So whenever the two objects are moving in different directions, their velocity will add up. So the train will appear fast. That is why when you are sitting in a train and you are observing the train which is moving in the opposite direction, you will see that the train just moves fast, right? So it just quickly goes through the other thing, right? So whenever the trains are moving in opposite direction, they will appear fast.
Yes, sir.
And we can take the same example as well. So let's say that the two objects are moving in same direction, right?
Yes, sir.
Then their velocity, relative velocity will be getting subtracted. So this will subtract it and it
In
will
same
come v1 minus.
direction.
Yeah. So this will be subtracted because they are moving in the same direction, right?
Sir.
So that we have done in the past as well when we were talking about motion in one day. So when where it will be what is okay. Yeah, this one we have done, right? So okay, which is happening. Yeah. So after free fall, we did relative motion.
Yes,
And
sir.
we say that whenever the two objects, right, whenever when they appear slow, when they are moving in same direction, they will appear slow,
Mm.
right? And when they are moving in opposite direction, they appear fast.
Let's do.
So that thing we have done, right? So
Yes.
we will do the same thing and right. So you understood that what is the relative motion, right?
Yes, sir.
Now let us understand,
So do I
right?
copy
So
down?
yeah, please note this one. So
Okay.
yeah, please note it. What is the subject that you are revising?
So chemistry.
So chemistry and physics. Biology is yeah. So biology we have to just
Biology, I'm very good at it. It's okay.
oh good. So, because the core subject that you
In
will
NEET,
have,
yeah, I
yeah,
know.
that is
Mm.
biology, right? So yeah,
Yeah, but for NEET, I need to do extra, so that's the
yeah,
problem.
yeah. So you just have to look at those reference books, right? So
Yeah.
but so what do we call? Hmm. What are the critical subjects, right? Because everybody prepares biology, right? In NEET exam, everybody prepares that. So the critical subjects are physics and chemistry, right?
Yeah.
So yeah, if we can do only the NCRT problems and we just remember then this would be very easy because physics and chemistry they are easy, relatively easy in each exam, right? So
Yeah, even our school sir had told that NEET, for NEET or
hmm.
any other competitive exam, if you do NCRT, it is the best book.
No, for JEE we have to look beyond NCRT,
Like
right? Because
for competitive NEET exam, like that.
yeah, well, for competitive NEET exam that is NCRT one is good, but for JEE competitive exam, you have to go beyond study because lots of syllabus have been trimmed down, right? So they have omitted certain parts of the chapters, right?
Mhm. Not for
But
NEET.
it need for NEET, yeah, not for NEET. So yeah, but there are some topics which are additional in NEET, but not more as compared to JEE. Because in
Okay.
JEE we have several topics which have been moved. So that we have to cover. But for NEET, yeah, NCRT would be
Okay.
yeah. Whenever you have completed,
So, 1 second. Yes, sir. Done.
Done.
Yes, sir. Sir, after this chapter, it's going to be theory, right?
Yes, what chapter?
After this chapter, it's going to be theory for the
Yes.
law. Everything.
No. So laws of motion, they have also numericals, and you have what work energy problems. They are the most important chapter, and they have lots of numericals, right? So
Okay.
lots of numericals. Physics, 50% theory, 50% numericals. So yeah, we have to cover both, right?
Yes, sir.
Okay, so the what are the problems that we have when we use this relative motion? So there is only one problem, right? And
There any
that is yes,
are there any formulas?
yeah, there are formulas. So we will not remember the formulas, but we will learn the concept. If we have the concepts clear, then we can always derive the formula, right? So yeah. So when do we use this relative motion idea? So we use this, right, when we do this Rainman problem.
Two? No.
Yeah, Rainman problem, right?
Yes,
And
sir.
in this one also, there is unknown. So this is a very important thing. When do we use relative motion in Rainman problem? So note one, that is when the observer,
Mm.
which is the man, right, or woman. So what did I? Yeah. So when the observer is not moving, then can we use this relative motion? Yes.
No, because both of the objects have to move.
Yes. So then we use resultant, right?
Mm.
And resultant of the vectors, if I may. And when the observer is also moving, observer is then we use relative motion. Right. So that we have to keep in mind when we have to use in Rainman problem, when we have to use resultant, when we have to use relative, right? So let's say that the rain is pouring down, right?
Yes, sir.
And let's say with okay. So why this is then we have the rain is pouring down with, let's say, 20 meter per second speed, right? And wind is blowing in, let's say, in the left direction, right? So wind is blowing in the left direction with speed. Let's say this is 30 meter per second. Let's write it as 30 meter per second. Wind is blowing in left direction with speed of 40 meter per second. Find the angle at which the man has to keep his umbrella to save him from the rain. Now, the man is stationary or moving. The man is stationary or moving. Yeah.
So he is moving his umbrella.
No, he has to keep his umbrella, right? So
Yeah.
the man is moving or not? That is the question.
He's not moving.
He's stationary. Let's say he's waiting at the bus stop, right? And the
Yes.
bus stop doesn't have any roof. So yeah, then he has to use his umbrella, right? So then where he has to put his umbrella, at what time? From the what, right? So let's make a diagram, then this would become simple. But before we make the diagram, let us understand a very important part of a triangle, right? That I have discussed, but let me see if you remember or not. So let's say I have this triangle whose let's say whose base is 3, perpendicular is 4, right? And hypotenuse would be how much?
5.
Yes, so hypotenuse would be 5. Yes, absolutely correct. Let's say this is theta, so this would be 90 minus theta, right? So whenever you have these kind of things, so if I calculate cos theta, this would be 4 by 5, right? And sine theta, this would be how much? This would be 3 by 5, right?
Yes, sir.
So this is 0.8 and this is 0.6, right?
Yes, sir.
Now you tell me that for which angle cos theta is smaller and sine theta is larger? For what kind of angles?
Sir, could you repeat which angle?
So for what kind of angles cos theta is larger, sine theta is small?
Um,
Did you understand this question?
no.
Okay, so you just consider two angles, cos
Okay.
30, sine 30, and cos 60 and sine 60. So these are larger angles. This one is small, this one is large, right?
Okay.
We are
Yes, sir.
talking about 0 to 90. So which value is smaller, which value is greater? Cos 30 is root 3 by 2, right?
Yeah.
Sine 30 is 1 by 2.
Yeah.
This is 1 by 2, this is root 3 by 2, right?
Yes. Yes.
So you see that for larger angles, cos theta is smaller. For smaller angles, cos theta is larger. Did you understand this?
Yes, sir.
Is it clear?
Yes, sir. For smaller angle, cos theta is smaller.
Cos theta is smaller.
For smaller angles, cos theta is smaller.
That is the opposite. You see, for large angles, This is less. So root 3 by 2 is how much? 1.7 by 2. So this is something 0.8 something. This is 0.5. This is 0.5. This is 0.2. So you see that for larger angle, sine 1 is larger. For smaller angle, sine is smaller. For smaller angle, cos is larger. For smaller angle, cos is, for larger angle, cos is small. Is it clear?
Yes, sir.
Okay, so if that is clear, then let me ask you that in here, theta is small or big?
Sir, in which?
In this one, this theta is larger or small? All this is just to remember one, that what angle would be
Larger.
larger. So you see that
4
this
by
value,
5.
yeah, that
4
is
by
large,
5 is larger, so its cos theta will be smaller.
smaller, right? So theta is small and the value is 37. Okay.
Yes,
In
sir.
here, again, theta is small. So cos for 4 by 5, always remember that this is, for this one, the angle would be 37. And cos 3 by 5, if you look at the diagram, so what would be this angle? Can you tell what would be this angle?
Oh, okay. One second.
He calculated cos theta.
Yeah. One second.
Think about it and tell me the answer, right? I will have lots of.
8 times 37. Oh,
So what would be?
oh.
Answer is written in your screen, right? So that is there.
No, 90 minus theta, right?
So, so what is that?
Oh, 90 minus 37, sorry.
So what is that? What is that?
Yes, sir.
So what is that answer?
Mm, 53 degrees.
So that would be 53, right?
Yes, sir.
So this would be 53. So let us remember this thing. So here theta is 37. Similarly, if I ask you tan 3 by 4, right? So in that case, what would be the angle? Theta would be what? If I write it in this way, so what is tan inverse 3 by 4? Right. Oh, why did I write tan? Okay, yeah, so that is wrong. I have to write it cos theta is 4 by, not the other way around, right? So that is a very wrong way to write.
Mm.
Yeah. 90 minus theta, and that is 3 by 4. Right, so yeah, this is the correct. So tan theta is 3 by 4. Then what would be theta? You just think about it and tell me the answer.
So tan theta is equal to 3 by 4. So
Yeah,
what
yeah.
is
So
3 by 4?
let me just give you a hint. cos theta sine theta is this thing. What was the angle?
37 degrees.
So sine theta is 3 by 5. Cos theta is 4 by 5. So tan theta is 3 by 5 by 4 by. So 3 by 4. So theta is 3 by 4. So what was this theta?
37 degrees.
So 37 degrees, right? So always remember that whenever you have tan inverse 3 by 4, so this would be 37 degree. If you have tan inverse 4 by 3, so in that case, theta would be 53 degree. So these are very important things
Sir,
that you have.
don't do this like in class or in school.
Yeah, yes.
They didn't teach us this again.
Yeah, this one is important because whenever you are doing this Riemann problem and all those things, and whenever you have these kind of triangles, 3, 4, 5, then for angle, this becomes very important, right? So you will get tan inverse 4 by 3 or you will get tan inverse 3 by 4. We'll see just this thing in this question. So
Yes,
in
sir.
this question, we will see this thing, right? So for that we have to remember this thing. Did you understand this triangle or any doubt?
No, sir, I understood.
Yes, just remember that if you have 3, 4, 5, then one angle beside 3 is 37. So now I can write it clear. Right, now we know all the things, so I can write it clearly that whenever you have 3, 4, 5, so this angle is 37, this angle is 50. Is it clear now?
Yes, sir.
So we will get tan 37 as 4 by 3.
Oh, okay.
Okay.
Tan inverse is 4 by 3, right?
Yeah. So did I do any mistake? Tan 3 by 4. Okay. Oh, cos theta is okay. Yeah. Yes. So this would be 3 by 5, right? So this would be 3. This would be 4. And everything in the different order, right? Okay, so this one is correct. Yeah, this one is correct, but this diagram is incorrect, right? So this diagram. So this is theta, and this is 19. Okay,
Yes, sir.
because cos theta is based by hypotenuse, right? So this should be this. So whenever we have this kind of diagram, right? So adjacent to 4 is 37 degree. Adjacent to 3 is 53 degree. Right. Is it
Yes.
clear to you? And if you don't remember this thing, so we can understand in this way that cos theta of cos 37 would be, you can tell me that 4 by 5 or 3 by 5. Which one is possible?
Sir, it's supposed to be 4 by 3, right?
5. The hypotenuse, I'm talking about cos.
Oh, cos. Okay. 4 by 5.
This one is larger, right? This one is
Yeah.
small. So just remember this thing and then you will get this picture. Because this picture is very important to understand. If we remember this one, so the angle beside 4 is 37, the angle beside 3 is 53. Right?
Yes, sir. Yes.
That is the idea of this question, right? So, yeah, please note this one down, right?
Yes, sir.
So, tan inverse 3 by 4, right? Now, if you look at the diagram, So tan and then 53. Tan 53 would be 4 by 3. Tan 37 would be 3 by 4. Right. Clear?
Yes, sir. Yes, sir.
Okay, so then please note down the question. And this one also we have not written, right? So note down from here. And then we'll talk about the next thing. Yeah, whenever you want me to scroll down, please tell.
Yes, sir. Sir, can you? Okay.
Yes, yes, yeah, please tell me.
Sir,
Should I?
nothing. Could you just zoom in a little bit?
Yeah, yeah, please, whatever you have, just tell me, right? So,
Yes,
is it all right?
yes, sir.
Yeah. Yeah, whenever you want me to scroll down, please.
Yes, sir. So can you scroll down?
Yes, is it okay?
Yes, sir.
So final thing is that you have to remember this, right? So this is the most important point, right?
Sir, which one?
This one has all the information, right? What
Yes,
is the
sir.
angle? What are the sides? So, yeah, this one is in. If whenever you have completed, please do.
Yes, sir. Yes, sir. Completed.
Now let us see this question, right? So what do we have? We have rain is pouring down, downwards, and then the wind is going in left direction, which is east or west. What is left direction? Yeah.
Mm.
If you look at
West.
left is west, right? So let us make that right. So rain is pouring downwards, right? And the wind is blowing in the left direction, right? So which means that this is your wind, this is your wind. And in this case, we are observing at this point. So let's say we are at here, right? The question is that where do we have to put the umbrella, right? So what do we calculate? Do we calculate relative motion? Do we calculate the resultant motion? What do we calculate?
Resultant, because we are not moving.
Yeah, so we calculate the resultant, right? So in that case, the resultant would be where? This is the parallelogram, right?
Yes, sir.
This rain is, what was rain? 30 meter per second. And this wind was how much? 40 meter per second. Right. So if we calculate the resultant, right? So that would be velocity of wind plus velocity of rain, right? And what is velocity of wind in vector form? Can you tell me what is velocity of wind in vector form?
Sir, V n plus V r I hat into I hat.
Minus 40i, right?
Yeah.
And what is the velocity of rain?
E G
Yes, so that would be 30 minus g.
minus J. Okay.
Right. Now, if we calculate the resultant, so let's say velocity of wind with respect to wind, so that would be, this is, let's say, W, and this would be simply minus 40i and minus 30g.
PG.
So that is the velocity. So what would be the resultant? This would be root of 40 square plus 30 square. But we are not calculating the magnitude. We are calculating where do we have to put the umbrella. So the rain is falling like this.
Yes,
That
sir.
is the resultant, right? So we have to put the umbrella in this direction, right? That is the umbrella.
Yes, sir.
And we already know that this angle, right? So let's say if we calculate this angle, right? So this angle would be equal to this one, or which one? Yeah. Right?
Yes, sir.
So how can we calculate this angle? Let us calculate, let's say this is theta, right? And for this theta, this would be base, this would be perpendicular, right? This is 40. So tan theta would be how much? Tan theta would be how much?
Sir, 40 by
By
30.
30, right?
Yeah.
So tan theta is 4 by 3. Now you see that what would be the angle? Then this
53.
theta would be how much?
53.
53, right? So this theta would be 53.
I have a
So
doubt.
yes,
So theta tan inverse is 4 by 3, right?
yeah. So if we take this theta, if we want to calculate this theta, so we have to take this function in the right hand side. So that would be tan inverse, right?
Okay.
So I have just written this directly, right? I have not written this. So this value we know that is 53 degree, right?
Yes, sir.
So we have to put the umbrella with 53 degree with the vertical right? And
Yes.
placed in what direction? So let's say if I call it so north and east direction, right? Northeast direction, right? 53-degree northeast direction. Is this one clear?
Yes, sir.
So that is the answer. Please note it down. And yeah, that is the answer to that question. So please note this one down. And then we will do the relative. So when do we have to use the relative motion? That kind of question, right? So yeah, please. So this is angle from the vertical, right? If somebody asks you angle from horizontal, so what would be that angle? What would be the angle from horizontal? Usually we take the angle, always, right? We always take the angle from the vertical. Just remember that. But let's say that if they ask angle from the horizontal, right? This angle. So what would be this angle? Not this would confuse. So let's say this is some alpha angle. So what would be alpha?
So theta is 53, then alpha is going to be 90 minus 53.
So that is 30, right?
Yeah.
So that would be this, yeah. So please note this one down and then we will do the next question.
Yes, sir.
So are you doing all those homeworks that I'm sending you? So have you done all those? Have you submitted all those homeworks?
So the portal one?